Welcome to the presentation for the Fall 2022 Research Translation Science Communication Workshop sponsored by CLEAR, the Center for Leadership in Environmental Awareness and Research at Wayne State University. This presentation is titled The Visualization of Scientific Information, Graphical Abstracts and Scientific Posters. What do you want me to know? My name is Judith Moldenhauer. I taught graphic design at Wayne State for 32 years and just retired in May 2022. My research and work focus on user-centered information design, especially in healthcare and data visualization. In this presentation, I want to provide you with some visual tools and insights to help you develop clear and effective graphical abstracts and scientific posters. While the presentation is specifically about graphical abstracts and scientific posters, and I'll be referring to them as GAs and SPs respectively, the information it contains applies to the display of all scientific information. The subtitle of the presentation, What Do You Want Me to Know?, is the key to and at the heart of all visualization. What is the one thing that you want me to take away from encountering your GA or SP? You may have a few things that you want to say, but you need to choose one thing to emphasize. The others will be there, but you need to focus on one thing. It's like writing a term paper. You have a thesis, and the paper is written to support that thesis. If you can say what you want to communicate in 25 words or less, you can stay focused and not get sidetracked. Once you know what you want me to know, you then decide how to present it. That is, its visual organization, what to show and how to show it. The result is a hierarchy of information. That is, what you want people to see and understand first, second, third, and so on. That will communicate to me what you want me to know. Now I'll show you an example of how the arrangement of information can communicate different things about that information. In this case, about breeds of dogs. In this slide, the dog breeds are arranged alphabetically, one breed per line. All the names are in the same typeface, size, and weight, regular weight, and a line left. This is called flush left, ragged right. In the next three slides, you will see the names arranged to communicate a variety of different characteristics about the breeds and the use of visual elements to reinforce that communication. Again, all the same breeds, but a different communication focus in each slide. In this slide, the focus is on the different sizes of the dogs. The breeds for each size category are grouped together alphabetically, and now have a heading in boldface type to identify each size. And this is in contrast to the list of breed names that uses the regular type weight. All the headings line up at the same place at the top of the list. This is a visual signal to help you recognize each grouping. Note what happens when a second column is needed to list the names. The top of the second column stays below the line where the headings sit. Here the communication focus is on the country of origin of the dogs. The breeds are grouped by country, and the countries are arranged alphabetically. The visual arrangement of the breeds from each country uses the typographic signals you saw in the previous slide, type size, weight, and alignment. But there's now a line space between each country group because there are lots of groups, and the number of breeds per country varies greatly. Here the communication focus is on the breed groups designated by the American Kennel Club. Again, the same information, but organized to tell you something different about the dogs. The use of alphabetical order and visual signaling you saw in the previous slides is also at work here. So now that you have a basic understanding of how the intersection of information and its visual arrangement relate to what you want to communicate, let's see how this all applies specifically to GAs and SPs. A graphical abstract is a visual summary of scientific ideas or findings and is the visual equivalent of a verbal abstract. The design of your GA needs to be based on what you want me to know about your idea or findings. A scientific poster is a combination of text and images that visually present your research. It can contain graphical abstracts and/or other kinds of data visualizations such as graphs, diagrams, and photos. And as with the GA, the design of your SP needs to be based on what you want me to know, in this case, about your research. Here's a list of important visual variables. Some sources cite additional ones, but this is a good basic list. We have already touched on size, weight, spacing, and placement during the discussion about visual organization of dog breeds. We'll cover all these visual variables in the course of this presentation. For more information on visual variables and to learn about systems of visual organization that could be helpful, but are not covered in this presentation, see my article, Visualizing Information in Scientific Figures, What Do You Want Me to Know? That's listed under Resources at the end of this presentation. In the next few slides, I'll show you how changes to one visual variable, weight, in lines in a diagram can change the meaning, or the communication focus, of that diagram. I designed this diagram for the Wayne State BEST NIH grant program, broadening experiences in scientific training that help biomed PhD students explore career paths. This diagram emphasizes the career paths using large, colorful shapes. The line weights are secondary to the shapes. But by increasing the weight of the line around the large circle, the emphasis now is on the best curriculum. Here the arrows exiting the circles are the boldest visual element, emphasizing that the curriculum can lead to various careers. This diagram was also designed for the BEST grant program and showed how BEST was integrated into a PhD course of study to provide career options upon graduation. By changing the visual variables of color and placement in the diagram, gray to black for years of doctoral study, and putting the PhD completion information beneath it, the meaning of the diagram shifts the focus to the number of years needed to complete the degree and ties that directly to the career paths. Edward Tufte coined the terms chart junk and data-ink ratio in his writings on information design. Chart junk refers to items in data visualization that are superfluous, merely decorative, and do not contribute to understanding the data itself. In the data-ink ratio, the more ink used in your data visualization, the more your actual data will be obscured by unnecessary visual stuff. Either you've got chart junk or are trying to cram too much data into one space. Tufte's advice, and mine, is to eliminate chart junk and keep the data-ink ratio in balance. In other words, only use what you really need. The following two slides provide examples of chart junk and skewed data-ink ratios. Here is the BEST diagram again, but this time with way too much ink. The colors have no relationship to the information, are too intense, and make some of the type hard to read. This graph is loaded with chart junk and uses far too much ink. Why would a bar graph need to transform its lines into ribbons, complete with shadows, and have them exist within a three-dimensional stage in order to effectively communicate its information? The extra lines, especially those used for the grid on the floor of the stage and for the ribbons, are superfluous and are just more ink on the page. The ribbon effect actually gets in the way of finding the data points and understanding the point of the graph. This slide and the next one give you tips on designing a GA. The GA tips on this page can be found in the article Proving the Value of Visual Design in Scientific Communication by Karen Cheng et al., which is included in the resource list at the end of this presentation. These tips are: keep design low to moderate in complexity. Eliminate redundant or non-essential elements. Do not be afraid of white space, that is the space around the elements in your design. Have clear start and stop points. Move from left to right and top to bottom. Use visual chunks or groupings to create your hierarchy of information. Use words, which are brief labels, to identify important elements and explain specific mechanisms. Draw your layout on paper, then transfer your design to the computer. I want to underscore this point. It's really important. There is no design key on the computer keyboard, and it doesn't matter what software you use for your GAs. You need to first think about your options for visualizing what you want to communicate. Once you have decided on the best option, then use the computer to generate your design. Use color to call out important points or make visual connection between information in your GA. Type should be aligned flush left, ragged right. Do not wrap type around images or use boxes around words or use unusual typefaces. Use arrows with discretion. Visual elements in the design should not compete for attention. Remember this last point, and remember to use the hierarchy of information. Your choice of visual variables and their arrangement will tell me the main thing you want me to know about your findings. In each of the next 4 slides, you will see an original published GA and its redesign using the visual variables and tips we have covered. These GA examples come from the Chang article, and more GA examples can be found in that article too. In this instance, the original GA shows a schematic of an array of silicon nanowires. When exposed to light, the nanowires photoelectrochemically generate hydrogen. In the original GA, this reaction, which is the communication focus of the GA, is difficult to see due to its small size. The revised GA uses larger close-up views so that the information about the reaction is more legible. The larger array is still shown, but as an instrument image. In this instance, the point of the original GA is to compare the function of microtubules in different temperatures, but that is difficult to comprehend because you must frequently refer back to the side legend in order to understand what is being shown. In the revised GA, elements are directly labeled, thus eliminating the need for the legend. With the larger type and the temperature at the largest and boldest typographic element, the GA can clearly show the relationship between the temperature and the functioning of the microtubule. The color backgrounds of each portion of the image now butt up against one another, further emphasizing the comparison that is at the heart of the GA. In this slide, the original GA you cannot easily see which material structure corresponds to its line graph and instrument image. Here the idea is to show the result of an experiment on 3 different materials. By removing the schematics from the graph and then aligning them together and pairing them with images, you can see the relationship between them more clearly and concisely, which is the point of this GA. In this original GA, the main components of the polymer PLGA and PEG and how they relate to becoming an islet-homing nanoparticle, which is the communication focus of this GA, are difficult to see. In the redesign, these blocks are enlarged and coded with both shape and color to enable faster visual recognition. Changes in size and weight and placement to the type reinforce the process. This slide shows the redesign process of a scientific image, how the image got to its improved version. The original GA shows the experimental setup. However, this design fails to highlight the key result, which is the development of a photoanode that yields significantly increased photocurrent density. Instead, the purple container, which is inconsequential, is highlighted and unintentionally linked to the purple instrument image, which is overlaid with a graph that is itself difficult to see. In the redesign, the anode is made visually prominent and is connected to the instrument image with color and graphic lines. In particular, the anode display no longer has chart junk, those textured shapes, curved wavy lines, extra arrows, gaudy arbitrary colors, and extra lines. The type is larger and aligned with the diagrammatic process, and the elements of the anode itself are rightly the visual focus of the display. Now you can understand that the structure and action of the photoanode results in the data shown in the graph. Now let's talk about scientific posters. Most scientific posters have these basic sections: introduction, methodology, results, conclusion, and references. Depending on what you want to communicate through your poster, the sections can have different headings, or you could have fewer or more sections. But in any case, think about which section is the most important to what you want to communicate. All the sections will be there, but which is the most important? This slide and the next two slides contain SP tips. Many of them will be similar to the GA tips, and that's because in both cases you are making decisions about how to visualize information. So, for your SP, use plain English, few words, be concise. Use color to call out important points or make visual connections between information. Use bullet points. Use a contrast of type weights. Bold for headings, Roman for text, large size for title, but smaller for text, and smallest yet for captions and references. Use few images, preferably one, maybe two. Text type should be aligned, flush left, ragged right. Do not use long line lengths, and do not wrap text around images. Draw your layout on paper, and then transfer your design to the computer. Again, this is really important. There is no design key on the computer keyboard. And again, it doesn't matter what software you use for your SPs. You need to think about your options for visualizing what you want to communicate first, and then go to the computer. Use negative space on the page. This helps organize and bring focus to the sections of your SP. Use color sparingly. Use it as an accent. Do not put type over background or ghosted images. It makes the type really hard to read. Do not use unusual typefaces. And visual elements in the design should not compete for attention. Remember that the hierarchy of information that you provide guides me through what to read first, second, third, and so forth, and that will tell me the main thing you want me to know about your research. Always print proofs of your poster before you print the final piece. Don't wait until the last minute to print proofs. You want to find mistakes before you have paid for the final output and while you have time left to make changes. Can your poster be printed with bleeds? If not, design accordingly. PowerPoint, by the way, does not allow bleeds, so you don't need to worry about this if you're using PowerPoint to create your SP. Print your poster on matte, not glossy paper. This prevents glare when it's displayed. Print from a PDF file. Make sure that images are 300 dpi. Check the image size of your photos. Photos from most cell phone cameras and images taken from the internet are 72 dpi and need to be adjusted. Do not enlarge pictures past their 100% size. If you do, the pictures will have the jaggies. Whatever the original size of your photo is when you place it in your design, you should not enlarge it any further. You can go smaller, but not bigger, unless you adjust the DPI. Pixel-based images, like photos, are fixed and won't reconfigure, unlike vector-based images created in drawing programs like Illustrator. These can be enlarged beyond 100%. This is one guide for type sizes to be used in SPs. It is from the Wayne State Library System Guide, Creating a Research Poster. Your own type size that you use may vary. Type size, by the way, is measured in points, and the space between lines of type is called lettings. You want to have a good amount of leading. Too little leading will make the type hard to read. Here is a poster I designed for the World Association of Infant Mental Health Conference in South Africa. I worked with nursing colleagues to develop materials to help women recognize symptoms of and get help for postpartum depression. The main point of this design was to show the content of our phone app and how to navigate through it. Second was to show the different formats in which the content and navigation appeared. Take note of how visual variables of size, weight, shape, spacing, color, and placement are used in this design. The following several slides contain the format for clear posters with hypothetical poster design examples, showing variety in the number of columns, orientation, horizontal and vertical, and specific communication focus. While the overall point of each poster is to explain that when nanowires are exposed to light, each nanowire will photoelectrochemically generate hydrogen. This is the image for each poster that has been borrowed from the Cheng article. A couple of posters will focus on just this process. The type arrangements and image choices in these poster examples will demonstrate some of the choices you can make about visual variables and the hierarchy of information to effectively communicate what you want me to know about your research. The text in these posters is Latin. That is, there's no specific content. It's just being used as a placeholder. The typeface is Arial, and the type sizes on leading are text type, 36 point with 12 points of leading. Headings, 48 points with 12 points of leadings. And the large image heading is 60 points with 20 points of leading. That's used on the 5-column horizontal and 3-column vertical. In this example, in this slide, you see the 3-column option. The image spans 2 columns. The text sections under the image would have more of a connection to the image since they are directly under it. Maybe these are the results and conclusion sections, plus references, but that could be different depending on what you want to emphasize. Here is the 4-column option. One section of information directly under the image gets more space, indicated by the line above the heading, because it talks more specifically about the process shown in the image. The other sections under the image could be supportive of more detailed information. Here's a variation on the 4-column option. Information directly under the image would be specifically about the image. The color background placed behind the image and text visually emphasize their connection to one another. The dotted line is used to indicate the text below is closely related to the image, as opposed to solid lines used to separate sections. The left-hand column could be containing an introduction or other supportive information. Note that the color background is a tint. It's an 80% transparency, so it does not compete with the color in the banner at the top of the poster. This slide shows the 5-column option. In this arrangement, the image is cropped to focus specifically on the process within an individual fiber. There are fewer headings. Think about combining your information in new ways and using different headings. This slide shows the 3-column option in its vertical orientation. Again, the focus is specifically on the process of an individual fiber, emphasized by the image spanning the width of the poster. The text that most relates to the image has a color background that lies directly under the main part of the image. Again, the color background tint does not compete with the banner at the top of the poster. The next set of slides provides a resource list for the design of GAs and SPs. On this slide, you see two links that are specifically about the design of SPs. Here's the information about the Cheng article and a link to the source of the terrible bar graph you saw. This is information about my article and the Tufte book that I recommend. The author Bang Wang wrote a column in the journal Nature Methods with tips for the design of scientific information that echo the points made in this presentation. Here's the information about how to access his writing. Now it's your turn to create GAs and SPs. The following 2 points are crucial to creating a successful GA or SP. Decide what the most important thing is that you want me to know. And once you know what you want to communicate, start drawing layout ideas to figure out how to organize your information into a design that can clearly communicate your ideas and findings. And have fun. Thank you very much.